Welcome everyone. Today we are going to discussing about a heat treatment process. So before going through the method of heat treatment process, let us discuss about what do you mean by heat treatment process. The process of heat treatment is carried out first by heating the metal and then cooling it in the caustic soda solution, rain, water, oil or air. The purpose of heat treatment is to soften the metal, to change the grain size, to modify the structure of the material, and to relieve the stresses set up in the material after hot and cold working. The various heat treatment processes are commonly employed in the engineering practice are as follows. The first one is annealing, second one is normalizing, third one is hardening, fourth one is tempering, fifth one is matte tempering, sixth one is hash tempering, seventh one is hardenability. And these seven methods are the types of heat treatment process. In this seven type of heat treatment process, the heating of the metal and cooling of the metals are not same. It's a different for all the types of heat treatment, because in annealing or as compared to that of another heat treatment process, the heating temperature of the metal is different, as well as cooling method is also different. And as not only the cooling and heating methods and properties, okay, the what we need to improve, okay, the which properties we need to improve, like electrical properties or mechanical properties or the personabilities properties or hardenability, this or some other properties is also different from each other. Let us discussing about one by one. The first one is annealing. Annealing is intended one of the most important heat treatment process, and the next is the first main objectives of the annealing. The main objective of the annealing is to reduce the hardness and increase the ductility. The main objective of the annealing is the reduce the hardness and increase the ductility. The internal structure of the metal gets stabilized through this process. This heat treatment is given to the metal so as to achieve one of the most of the following objectives. The first one is to refine the grains and provide a homogeneous structure. Okay, uh, take an example of production in the production, like a forging. In the during the forging, the forging will be carried out to give a proper size to the material. Okay, okay, and in that time giving a proper size in using the forging, we required a hammering. Required to hammering on the object. On the time of hammering, the grain sizes will be disturbed in the material. Okay, and to refine that grain size will be and provide a homogeneous structure. To relieve the internal stresses set up during the earlier operation. Take an example of hot working or cold working. Okay, during the hot working or cold working, some internal stresses will be set up in the material. To remove that internal stresses, okay, we need to go through the annealing heat treatment process. The next one is to soften the metal and thus improve its machinability. And next one is to effect changes in some mechanical, electrical, and magnetic properties. Next one is to prepare the steel for further heat treatment process. Next one is to dry out the gases trapped during the casting. Means to dry out the casting means, okay, this during the casting, okay, the casting, I might have know the casting process. Casting process means, okay, casting process will be carried out by The casting process, we are going to melt the material to a liquid state, and the molten material we are going to pour into some patterns. During that solidification means, so after some time it will get solidification and it becomes hard. During the solidification, some gases will be going to escaping from the top of the pattern. During that, some gases will be entrapped inside of the metal only. So this entrapped gas inside the metal, it will makes the porosity inside of the material. This porosity leads to the material weak. So it will make a product to a weak. So that to dry out that such type of the gas trapped during the casting, it will be removed by using the annealing heat treatment process. The next one is to produce a designed microstructure. Annealing. In annealing, there are four types, okay, in the subtypes of annealing process. The first one is process annealing, next one is polarizing annealing, the next one is diffusion annealing, next one is isothermal annealing. And these four types of annealing will be carried out at a different temperature and for the different applications. The first one is process annealing. The process annealing will be carried out at a temperature of 550 degrees Celsius to 650 degrees Celsius. To hold at this temperature for some time, and then it cooled in a slowly in the furnace only. Okay, not in this annealing process, the cooling method will be carried out in the not by means of water or air. The cooling will be carried out in the furnace only. And the next process is spherizing annealing. In that spherizing annealing, it usually applied to a high carbon tool steels which are difficult to machine. And the spherizing annealing will be carried out at a temperature of 730 degrees Celsius to 770 degrees Celsius. Next one is diffusion annealing. The diffusion annealing will be carried out at a temperature of 1100 degrees Celsius to 1200 degrees Celsius. And this diffusion annealing is also called as a homogeneous annealing and isothermal annealing. The name only indicates that isothermal. Isothermal is nothing but it will carry out at a high very temperature. This is all about the types of annealing methods. Next one is normalizing. Normalizing. The normalizing process is similar to annealing in the sequence but vary in the heating temperature range. Okay, in the previous heating process already we have discussed in annealing. In that annealing we discussed the four sub point of annealing. The temperature of the process annealing is different and the spherizing annealing is different. As the in that case normalizing is also temperature range is different, and holding time and the rate of cooling is also different. Heating temperature of the steel in the case of normalizing is 40 degrees Celsius to 50 degrees Celsius above the higher critical point, held at a temperature for a relatively very short period of time, or in that case of 15 minutes, and then cooled down to a room temperature in a still air. Means in this particular type of normalizing heat treatment process, the cooling will be done in the temperature in a still air, okay, room temperature in a still air. But in the case of annealing, the cooling will be done, okay, cooling will be going to carried out in the furnace only. Okay, but in this case of normalizing, cooling will be carried out in the room temperature in a still air. Means we are not going to carry it, cooling will be do not going to carried out in the furnace, it will be carried out outside of the furnace, means to say room temperature in a still air. This heat treatment is commonly used as a final heat treatment for such articles which are supposed to be subjected to higher stresses during the operation. Normalizing due to this heat treatment, internal stresses caused during the previous operation is removed, and internal structure is refined, and to fine grinds and mechanical properties of steels are improved as compared to that annealed steels of the some composition. The normalized steel will be less ductile but stronger and harder. But in that case of handling, the hardness will be low and ductility will be high. But in this case of normalizing, ductility will be less and hardness will be very high. For improvement of a mechanical properties, normalizing process should be preferred and to attain a better machinability, softening and greater removal of internal stresses. Annealing process should be employed. This is all about the normalizing heat treatment process. Next one is next one is hardening. In this hardening process, this process is widely applied to all cutting tools. The main objectives of a hardening to increase the hardness of the metal so that it can be resist wear, and to enable it to cut the other metal, so that is to make it to a suitable for tools, suitable for cutting tools. All machine parts made from alloy steels, dies, and some selected machine parts subject to heavy duty work. In hardening process, steel is heated to a temperature within the hardening range, which is 30 degrees Celsius to 50 degrees Celsius above the higher critical point for hypoelectric steels, and by same amount above the lower critical point for hypoelectric steels, holding it at the temperature for a sufficient time to allow it to attain austenitic structure and cool rapidly by quenching in a suitable medium like water, oil, or salt bath. Means we have to see here in the annealing process the temperature, the heating temperature is same, different, and the next cooling method is also different, and in normalizing also heating temperature is different, and the cooling method is also different. In that case of hardening is also the heating temperature, means the the temperature degree Celsius of temperature is different, and the cooling method is also different. So, in the annealing method, the cooling will be carried out in the furnace, and the normalizing carried out cooling method will be carried out in the room temperature still air. But in this case of hardening, the cooling will be carried out by means of a quenching, okay, in the water, oil, or salt bath. The quenching is nothing but cooled suddenly. Okay, quenching means it cooled suddenly. In the process of hardening, the steel is developed in such a controlled condition and by rapid quenching. So, already I explained the meaning of quenching is nothing but sudden cooling. After heating the metal in the furnace, okay, and allowed it to some particular time in the furnace to rise up the temperature. After that rising a temperature to a required temperature to hardening, and the metal will be taken out and it will be quenched, I mean it will be cooled suddenly by dipping it into a water. Okay, the transformation means the transformation is nothing but hot surface to cool surface, because in the furnace the material is in the hot condition. Okay, and when you're dipped in the water, the material will be becomes in a cooled, means the surface of the metal is cooled. Okay, that transformation is disallowed at a lower critical point, and by doing so we force the change to take place at much lower temperature. And by rapid cooling, the time allowed to a metal is too short, and hence transformation is not able to occur at a lower critical temperature. So this is all about the hardening heat treatment process. The next one is tempering. Next is tempering. A hardening steel piece due to martensite structure in extremely hard and brittle, due to which it is found unsuitable for most practical purpose. So a subsequent treatment is required to obtain the desired degree of toughness at the cost of some strength and hardness to make it suitable for use. So, in the previous heat treatment process, what I explained, the hardening heat treatment process. In the hardening heat treatment process, main objective is make the material to suitable for a cutting tool, and the another main objective or another main aim is to make the material hard and brittle. So, in the case of ductile and hard and brittle material, as in the case of stress strain diagram, okay, stress strain diagram as compared to that of the ductile stress strain diagram and brittle stress strain diagram, the breaking point will be very low in a ductile material as compared to that of the brittle material. In the particular case of brittle material, the breaking point is very high. It will be break very soonly as compared to that of the ductile material. So the aim of the hardening is to make the material brittle and hard. So it makes the unsuitable for the some operations. So to overcome that disadvantage, we require a tempering heat treatment process. This tempering heat treatment process will be makes the brittle and hard material into a tough material, means a toughness. Okay, and to make suitable for the you for some use for some for other operations. It is especially true in the case of tools. In this exactly what is mainly aimed at through tempering of a steel. This process enables transformation of some martensite into ferrite and cementite. So martensite is related to a brittle and hardness, and this ferrite and cementite is related to somewhat in a ductile. The exact amount of a martensite transformed to a ferrite plus cementite will be depend upon the temperature. Yes, of course, the transformation of martensite to ferrite or martensite to cementite, it depends upon the heating temperature. Heating temperature at what degree Celsius we are going to heat the material, to which the metal is reheated, and the time allowed for the transformation. The types of tempering. On the basis of ranges of temperatures to which the components are reheated for tempering, the tempering procedures are classified as follows: low temperature tempering, medium temperature tempering, and high temperature tempering. Means this low, medium, high temperature tempering, these are depending upon the rate of temperature at which the material is going to heat. So, depending upon the temperature, these three types of temperings are classified. This a lot about the tempering heat treatment process. The next one is mark tempering. Mark tempering is also known as a stepped quenching or interrupt quenching. Means stepped quenching means somewhat if you quench one time and next and quenched on the next time, means the stepped quenching, why we have carried out the stepped quenching will discuss in the next following process. Means In this process, in the matte tempering process, the steel is heated the above critical point. Means above critical point means up to this point. Okay, means the lower critical point. In this lower critical point, there is no transformation will takes place. But in the case of upper critical point, transformation will be starts. Okay, transformation range will be starts, and then quenched in the salt, oil, or lead bath, kept at a temperature of 1000, sorry, not 1000, 150 to 300 degrees Celsius. Okay, means, and the next workpiece is held at this temperature above martensite start point until the temperature becomes uniform throughout the cross section of the workpiece. After that, it is cooled in the air or oil to a room temperature. Okay, in this case also cooling will be carried out by means of air or oil to a room temperature. The steel is then tempered. Okay, means steel will be going to be tempered. In this process, austenite is transformed to a martensite. Mean, you might I know the what you mean by austenite and the martensite. Okay, let us discuss about the what do you mean by austenite and the martensite. Okay, martensite. The first one is austenite steel. It means in austenite steel is contain the high content of both chromium and nickel are called as austenite stainless steels. The most widely austenite steels are contains 18% of chromium and 8% of nickel. Such steels are commonly known as 18 by 8 steels, and these steels are non-magnetic and possesses greatest resistance to corrosion and good mechanical properties at evaluated temperature. And in the case of martensite, okay, in the case of martensite, the chromium steel contains 12 to 14% of chromium and the 0.12 to 0.35% of carbon is called a martensite stainless steel, and these steels can be easily welded and machined. These are the austenite and martensite. Okay, and in this process of mar tempering process, mar tempering heat treatment process, austenite is transformed to a martensite by step quenching at the rate fast enough to avoid the formation of ferrite, pearlite, and the benite. Okay, this is all about the mar tempering heat treatment process. The next one is as tempering. As tempering is the heat treatment that is applied for a ferrous material. Okay, as tempering is not going to apply for a non-ferrous material. It is going to apply for the ferrous. In the ferrous means in the ferrous material means in the ferrous, iron is a main constituent. Iron is a main constituent in the ferrous material. Most notably, steel and ductile iron. In steel, it produces a benite microstructure, whereas in the cast iron, it produces a structure of acicular ferrite and high carbon stabilized austenite known as asferrite. It is primarily used to improve the mechanical properties or reduce and eliminate the distortion. The as tempering is defined by both the process and the resultant macrostructure. Typically, as tempering process parameters applied to an unsuitable material will not result in the formation of benite or aspherite, and thus the final product will not call the as tempered. The both microstructures may also be produced via other methods. For example, they may be produced as a cast or hair cooled with a proper alloy content. These materials are also not referred to as tempered. The next batch, as soon as heating and holding the periods are over, normalizing is used. Improve the grain size, refinement, and machinability of the cast structure of the casting. Recover the original mechanical properties of the forged or cold worked steels. Easy the forging operation for high carbon steel and stress relieving of a castings. So, in stress relieving of a casting means in the casting we are going to a process of hammering. Okay, we make the in the casting, not in the casting, in the forging. Okay, in the forging we are going to hammering on the object. In the casting we are going to pour the mold or a liquid material into a pattern. So during that solidification, and in the case of casting and in the case of forging in hammering process, okay, in the both the process some internal stresses will be developed within the inside of the metal. Okay, that stresses will be released okay, in the ash tempering heat treatment process. Okay, this is all about the ash tempering heat treatment process, and let us discuss about the hardenability. Hardenability. The hardenability means okay, do not relate with the hardening heat treatment process, because hardenability is not an heat treatment process. Hardenability is a property of the heat treatment process. Okay, so after the heat treatment process, hardenability, okay, the property we are going to improve the some types, okay, some of properties. In that properties, hardenability is one. Okay, hardenability is nothing but the depth to which the material is hardened after putting it through a heat treatment process. At what depth material is hardened. It should not confused with the hardness, which is a measure of a sample's resistance to indentation or scratching. Indentation or scratching is nothing but it is going to describe the hardenability of the material. Okay, it is an important property for welding since it is inversely proportional to weldability, that is easy of welding of material. So we might all know that welding process. So welding is a permanent joining process. The permanent joining process means the welding zone should be very hard, because because it is a permanent joining. When a hot steel workpiece is quenched, okay, when the hot workpiece is quenched, I'll go quenched. So already I explained what you mean by quenched. Quenched is nothing but sudden cooling. Quenched means quenched means sudden cooling. The area in contact with the water immediately cools and its temperature equilibrates with the quenching media. The inner depths of the material, however, do not cool so rapidly, and in a workpiece that are large, the cooling rate may be slow enough to allow the austenite to transform fully into a structure other than the martensite or bernite. This results in the workpiece that does not have the same crystal structure throughout its entire depth, with a softer core and outer shell. The softer core is a combination of ferrite and cementite such as a perlite. Hardenability of ferrous alloys, that is steel. Okay, so already explained the ferrous means iron is the main constant, is a function of an carbon content and other alloying elements and the grain size of the austenite. Means hardenability is not same for the all types of the material. It also depends of the content of the materials. Okay, and also the grain size of the material. The relative importance of the various alloying element is calculated by finding the equivalent carbon content of the material. So, as compared to the law of the ferrous and non-ferrous, the carbon content of the material will be very high in the case of ferrous. So, As in the case of as in the case of carbon content, so the hardenability is also very high, and also the grain structure. Okay, in the grain structure is also to a relative to the directly related to the hardenability of the material. And next one is the fluid used for quenching. Means the fluids. Okay, the first one in the first only I explained the types of mediums. Means types of cooling medium means air, water, or carbon solutions or brain. Okay, these all are the media for the quenching. Okay, in that the hardenability is also defined. Okay, is also dependent on the quenching media. Means that the materials influence the cooling rate due to varying the thermal conductivities. Okay, and the specific heat. Substance like brine and water cool the steel much more quickly than the oil or air. If fluid is agitated, cooling occur even more quickly. The geometry of the part also affected the cooling rate. Okay, the two samples of equal volume, the one with the higher surface area will cool faster. I means hardenability is entirely depends upon the shape and geometry structure and method of cooling and the carbon content and the grain structures. Okay, and these are all directly related to the hardenability. So hardenability is the property after the heat treatment process. So this is a law about the okay heat treatment process. Thank you.